Hello, this is question 5 on your January 2024 international paper from Edexcel, from the Core 3 paper. It's an exponential, modeling with exponential question that is very typical in all Edexcel papers. So we have temperature in Celsius of the air in a room 10 minutes after a heat source is switched off is modeled by this equation. And for this type of questions, I would really recommend you to do a quick sketch, or at least mental, of what is happening, because it's going to help you to understand the question. So if you look at this function, remember an exponential does this, yeah? When this exponent is negative, instead of increasing, the exponential decreases. So it has an asymptote in the zero. And if we are adding a number, we are just doing a vertical translation. So the whole function goes up by 10. So instead of this situation, we have this situation, where the asymptote is in the 10. This would be the time, and this would be the temperature. The time cannot be negative, so if you ever have to sketch this function, just don't draw the negative part, yeah? That's the idea. That's what is happening. So the temperature in the room, when you turn the heating off, goes down, which makes sense. And the minimum that temperature can be is going to be 10 Celsius. So now, they say A and B are constants, and given that the temperature of the air in the room when the heating is turned off is 18 degrees, we have to find the value of A. Because we are starting to measure the temperature when T is 0, so when the heating is turned off, what they are telling us is the temperature when the time is 0 is 18 Celsius. Yeah, so when T is 0, T is 18 Celsius, which means if we substitute here, we can easily find A. So temperature 18 is equal to 10 plus A, e to the power of 0 times B, so 0, this is 1, remember, so A is going to be 18 minus 10, which is A without units, because it's a constant, yeah, 8. Then, given also that exactly 45 minutes after the heat source is switched off, the temperature is 16 degrees, we have to find B. Now we know A, so we have only one unknown. We are going to substitute this again here and find B. Be careful, because this question is typical, that they give you the temperature in minutes, for example, here, and they say an hour. Yeah, so be careful not substituting 1 by substituting 60. Be aware of the units. They are usually something that they change. So T is 45 minutes, and then the temperature is 16 degrees. So we substitute 16 degrees, 10 plus 8, e to the power of minus b, and the, I don't know if you can see, but minus b, t is 45, yeah? So this is our equation that we are going to solve. So we have 16 minus 10, 6 is 8e, and I'm going to write this the other way around because we are more used to. So if we simplify, we have that e to the minus 45b is 6/8, which is 3/4, no? 3/4. If we take lengths, we have that minus 45b on the left is going to be length of 3/4, which means b is length 3/4, which is negative because it's smaller than 1, divided by minus 45. And when you do this with a calculator, you just get 0.0063923 significant figures. Again, it's a constant, so I'm not going to write units. Yeah. Then, using the values of A and B, we have to find, according to the model, the rate of change of the temperature in the room exactly 2 minutes after the heating was off, and in Celsius per minute to 3 significant figures. Please be careful with these questions, because it's very tempting to just find the temperature. That's not what they are asking. When they say the rate of change, and sometimes in the questions even is like bold, yeah, so it's highlighted, they are not asking you the temperature, they are asking you the derivative. So the rate of change is the derivative. So what we are going to do is to find the derivative and then find the value when t is 2 minutes. When we derive this function, the 10 is gone, and then we have remember a was 8, so I'm going to actually write the function here on one side with a constant. So this is 10 plus 8 e minus 0.00639t. So let's go into derivate that. We have minus 0.00639 times 8 e to the minus 0.00639t. Yeah, and now when t is 2, so what we are going to do is, so we are using just this to remind us, yeah, and when t is 2, we substitute, and with the calculator we find that is minus 0.050523 significant figures again. We can write the units for this one because it's Celsius per minute, yeah, to 3 significant figures. So when you have units, please just write them down. The next bit, it says, explain why, according to the model, the temperature of the air in the room cannot fall to 5 Celsius. Remember the sketch that we did here? Minimum temperature is 10. So just looking at the model, you can say, because minimum temperature will be temperature is 10 Celsius, because this when t tends to infinity, when this increases and increases and increases, because of the negative, this is decreasing and decreasing and decreasing. So this tends to 0, yeah? So this is going to be 10. You can say this, or you can just try substitute the 5. So if you try substitute the 5 in the equation, yeah, to prove that that's not possible to be 5, you will have this situation. So wherever you want or you feel more comfortable explaining. So if we substitute the temperature by 5 and try to find t, what we have is 5 minus 10 is minus 5 is 8 e to the minus 0.00639t, and we have e to something equal to a negative number, and that's not possible, remember? Because if we try to take lengths, we cannot take the length of a negative number, yeah? So it's not possible. So not possible. So either way, you don't have to justify you don't have to justify both ways. So you can just explain that the minimum temperature is 10 because of the model, or you just try to make that 5 and see that that's not possible to find the temperature. Yeah, the time. And that's all with this question.